triangles are totally awesome when it comes to trigonometry because we can figure out everything about them by using Pythagoras and our SOHCAHTOA trigonometric identities. But what about every other triangle out there that is not right? And by not right, I don't mean wrong, but I mean oblique. An oblique triangle is any triangle that doesn't have a 90-degree angle. What can we do with these sad, poor little oblique triangles? It would be so useful if we could do something with these oblique triangles. For example, I think of the time the HMS Theodore was heading towards a dangerous outcropping of rocks that were located southeast of a lighthouse. He radioed the lighthouse operator.
This is the HMS Theodore. Come in, lighthouse.
This is the lighthouse.
How far am I from these rocks?
Well, I know that we are 1.3 kilometers from the rocks over here at the lighthouse.
That doesn't help me. How far am I?
Calm down, sir. From our vantage point, we can see that there's a 63-degree angle between you and the rocks.
A big whoop-de-doo. I can see that the angle between you and the rocks is 53 degrees, so clearly we are in an oblique situation.
So far, we have learned that an oblique triangle is any triangle that doesn't contain a 90-degree angle, such as this triangle here. We don't have to leave it to that, though. Put on your explorer costume, or at least an inquisitive mindset, and let's go on an adventure. We're going to explore this triangle in all of its obliqueness, just because, just to see if there's anything interesting to discover here. Let's try and walk in the shoes of some of the great explorers of math, such as Pythagoras, Descartes, and Newton, to see what we can discover about this triangle here. To start us on our journey, let's label the corners of this triangle as A, B, and C. Let's also label the sides, but with lowercase letters. The side opposite of angle A we will label little a. The side opposite of angle B we will label little b. And the pattern continues for the side opposite of angle C. This opposite thing is really important, so pay attention to labeling the opposite angles and sides the same. So now we have a way of describing the different parts of any triangle that comes our way, which is actually the established convention for labeling triangles in mathematics. So let's play around with this triangle a little bit. What if we were to draw the perpendicular height of the triangle using side C as the base? Well, we would get a line that looks like this. That's actually kind of interesting, because now we don't just have an oblique triangle, now we have two right triangles. And right triangles, we know that we can use our trigonometric